Okay, so yan. So let us discuss our the second half of this chapter. Yung first part ng chapter na to, yung alkanes. Discuss natin yung continuation na. So last time we were able to discuss the normal chain ng alkanes, no? Yung straight chain kung saan zigzag lang yung nakikita nyo. So another version of alkane is the cyclic alkanes or the cycloalkanes, no? From the word itself, cyclo meaning nun pa-circle, okay? Pa-round, no? Yung chain natin. Kasi pag normal chain yan, normal aliphatic chain, yun ay zigzag lang. Pero kapag cyclic alkanes, that is pa-circular siya, no? Okay. So, what are cyclic hydrocarbons? These are hydrocarbons that contain carbon atom joined to form rings, no? And yan, so ito yung mga uri ng ating cyclic alkanes or cycloalkanes. So we have here the cyclobutane. So cyclobutane, square yung kanyang drawing, no? Pero ang interpretation natin dito sa square na to, at each vertices you have your carbons there, no? So we have carbon here, carbon there, carbon dyan, carbon doon. So we have 4 carbons here. What is the prefix for 4 carbons? But, di ba? So butane siya. However, it is circular. So ang kanyang name ay cyclobutane. Okay? So ganun lang. So 4 na carbon, ano yung prefix? But, no? Ito ay alkane, butane, no? And cyclic siya, pa-circle siya. So, cyclobutane, no? Okay, so, ano pa kailangan natin malaman dito? We should be also able to determine the hydrogen count for each carbon atoms, no? For example, sa carbon na to, ilang hydrogen yung pwede? Dalawa. Bakit? Kasi this carbon has already 2 bonds. Ilang bonds kaya? 4, di ba? So that means may pwede pang kumabit na 2 hydrogens here, no? Kaya CH2 itong part na to. This part, ganun din. So may 2 bonds na. Okay, may dalawang bond na dyan. So pwede pa yung dalawang hydrogen. So another CH2 and so on and so forth, no? So mostly kapag naka-circular, puro CH2 yung carbon sa vertices ng circle, no? Or ng ring, no? Okay, so that is cyclobutane, no? Another one is the cyclopentane. Okay, ay, nawala. So, ano meaning ng cyclopentane? So, pent meaning may 5 carbons, no? Pent, 5 carbons. So, ilang carbon meron tayo dito? 1, 2, 3, 4, 5. Pentane, no? However, this is in a ring fashion, so that means we have to affix the prefix cyclo. Cyclopentane. 5 carbon attached as a ring, no? Cyclopentane. Okay? And as usual, puro CH2 yung nasa dulo ng ating circle. No? Mostly CH2. CH2, 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 so on and so forth. No? Okay? Another version of cycloalkane is this one. This is a 6 carbon ring. We name it cyclohexane. Okay? So, ayan, cyclohexane, hex kasi, 6 na carbon. So, 1, 2, 3, 4, 5, 6. Okay, so we have 6 carbons there. And then, it is in a cyclic fashion, nakaring siya. So, cyclohexane. So, ganun lang. Ang wala lang cyclo is yung methane and ethane kasi you cannot form rings with them. Yung dalawang carbon, di mo pwedeng ikutin yun, no? Bawal yun. Okay? So, ano lang yung merong cyclo? You start with propane, no? Cyclopropane. Ano yung tsura ng cyclopropane? Triangle. So, dyan lang po nag-uumpisa yung ating cyclic hydrocarbon sa cyclopropane. Then, going beyond na, no? Cyclobutane, cyclopentane, hexane, heptane, etc. etc. Okay? So yun, so our cycloalkanes can have ring sizes from 3 to over 30 carbon atoms, no? Okay? And usually, what we see in nature ay yung 5-membered ring and 6-membered rings, the cyclopentane and cyclohexane. No? So these are the two common cyclic alkanes or cycloalkanes in nature. No? So most of the time, we will observe cyclopentane or cyclohexane, no, in our activities. No? So yun lang. So how to name our cycloalkanes, no? So in naming your cycloalkanes, you check the ring, no? Yung ring, yung pabilog, bilangin mo kung ilang carbons meron doon. Okay? So for example, we have 5 carbons. So the prefix to be used there is pent, no? So pent ibig sabihin nun 5 carbons. Hex, ibig sabihin nun 6 carbons. Oct, meaning nun 8 carbons, plus the suffix "ane", no? So, parang nagne-name ka lang din ng alkanes, no? However, if that is in a ring fashion, you have to add the prefix cyclo. Naglalagay ka ng prefix sa prefix mo. Okay? Cyclopentane, cyclobutane, no? Cyclopropane, etc. No? So, ganun lang yung pag-name ng iyong ring. Okay? If there are substituents, for example, if you have only one substituent, you do not have to give its location number. You do not have to assign any locants to it, no? So unlike alkanes na kailangan maglagay ka ng locant, for cyclic compounds, kapag isa lang yung substituent mo, not necessarily needed yung number or yung locant for your substituent. One example would be here, isopropyl cyclopentane. Paano naging ganyan yung name niya? So, first of all, we have this ring compound, 1, 2, 3, 4, 5. So, 5 carbons ito, di ba? 1, 2, 3, 4, 5. So, ano meaning niyan? Ang name niya ay cyclopentane. That will be your parent chain, no? Itong ring na to yung magiging parent mo, cyclopentane. Then, you check this substituent, no? So, ano yung name ng substituent na yan? Okay, so if you are familiar with the common names, no, ang name niya would be isopropyl, no? If you have forgotten the names of the common substituents, pwede nyo naman balikan itong slide na to, no? So, I told you last time, no, ang isopropyl ay letter V from the parent chain, di ba? Okay, so what we have here is the same, no? May pa-letter V tayo from the parent chain. Okay? So, yan. So, its name is isopropyl cyclopentane. Okay? However, if you have 2 or more substituents, then you have to assign a locant. Kailangan mo na maglagay ng number. Okay? However, dito sa cycloalkanes, medyo iba yung rules, no? If you are going to assign a number, bibigyan mo ng lowest number yung lowest yung alphabetical order. So, ang assigning ng number would be based on the alphabetization ng iyong substituents. For example, we have this one. Okay, so we have this substituent here na parang paa ng manok. So, that's third butyl, di ba? And then you have your methyl substituent here in your cyclohexane parent chain. So ito yung ring, ayan yung parent mo. Then yung mga nakadugtong doon, yun yung substituent mo. So you have your methyl, you have your third butyl. So who will get the first priority? Alphabetical yung arrangement natin, ha. The prefix says third, sec, and yung mga di, tri, etc. We do not count them when we are alphabetizing our substituents, no. So ibig sabihin itong third hindi mo yan papansinin when arranging the substituents alphabetically. So ang papansinin natin would be the letter B sa butyl, no. And then for this substituent, methyl yan. So, yung letter M. Who will go first? Butyl or methane? Edi, syempre, letter B muna, diba? So, we will assign locant number 1 for third butyl. And then, we continue numbering, no? 1, 2, 3, 4. Okay, so 1, 2, 3, 4. 4-methyl cyclohexane. Okay? So, ganun yung pag-name ha. So, bigyan mo na ng number 1 si mauuna alphabetically, which is in this case the third butyl because of the letter B sa butyl. Followed by the methyl. No? Dalawa lang naman yan. Hindi siya talaga yung susunod. No? So, yun. So, when assigning numbers, you always also have to check yung lowest priority. For example, teka lang, gawa tayo dito ng isa pang version. O kunwari, ganito naman. So this is the same. You have your third butyl and your methyl group. This is your cyclohexane. However, pag magna-numbering tayo, since ito ay paring, pwede tayong mag-go to the left or to the right, no? So, ano yung susundin dito? Okay. So, for example, this is your first carbon, di ba? Okay. So, we assigned first number 1 for this third butyl because of alphabetical order, no? Siya yung may lowest alphabetical order, no? So, letter B kasi. So, siya talaga may una. Then, that will be followed by this methyl group, no? However, in this case, no, dalawa yung pwedeng number niya. Pwede siyang 5 if we count it from left to right, no? So, pwedeng 5 yung kanyang locant, yung kanyang number, or pwede ring maging 3. So, in cases like this, ano gagawin natin? We will assign the lowest number, okay? Which is 3, no? So, ito yung susundin natin in this case, no? Okay? So, hindi siya magiging 1/3 butyl, 5-methyl. Now, it will be 1/3 butyl, 3-methyl cyclohexane. Okay? So, ganun lang yung naming, no? So, when naming your cycloalkanes, you name your parent chain, which is your cyclic compound, no? Ipapangalanan mo siya based on the number of carbon atoms it possesses, no? Check the number of carbon atoms in your ring now. So that would be the first step. Okay. So that will be followed by checking your substituents now. So name your substituents, list them, then arrange them alphabetically. Then you assign the number, no? The first number doon sa substituent that will appear to be first in alphabetical order, no? Siya yung pinakamababa yung alphabetical order, no? So, ganun lang yung naming for cycloalkanes. Okay, so with that, let's try to practice some cycloalkanes. Dito tayo. Ayan. So, we have 3 cycloalkanes here. So, pangalanan natin sila. So, okay, so let's have letter D. So, your cyclic ring here, ilang carbons meron dyan? 1, 2, 3, 4, 5, 6. No? So, this is your parent chain. Okay? So, 6 carbons meron dyan. So, your parent will be cyclohexane. Okay? So, ganun ha. Cyclo because it is in a ring fashion. Hex kasi siya ay naka 6 carbons. Ane kasi ito ay alkane. Puro single bonds lang meron tayo. Okay, so that's your parent chain, cyclohexane. Then your substituents. So what are your substituents? You have your methyl group here, CH3, methyl yan. And then you have your letter V, ano yan? Isopropyl pala. Okay. So, pag may letter V, ang name yan ay isopropyl. Okay? So, yan. Okay, so let's assign the numbers, no? By the way, who will come first, no? Sino yung mauuna alphabetically? Si isopropyl or si methyl? Check natin yung alphabet, no? HIJKLM, no? So mauuna yung I before the M. So I will give this my first number, yung yung isopropyl, yan yung magiging number 1 ko. Okay? Then for methyl, paano ko yan na numberan? Pwedeng 2 yan, o kaya pwede ring 6. Okay, so mamili tayo, which is okay, yun 2 or yun 6 for the methyl. Of course, mas okay yun 2. No? So we will assign the locant 2 for the methyl, 1 for the isopropyl, not 6 for the methyl, ha? Okay, so always the lowest number pa rin. Okay, so let's construct the name, no? Pagsamasamahin na natin yung idea ng substituent and our parent chain. So your parent chain will come last, no? Sa dulo natin yan ilalagay. Yung substituent, i-add natin siya. So who will come first? Still alphabetical pa rin yung arrangement, no? So that will be 1 isopropyl dash 2 dash methyl cyclohexane. Okay? So yan yung name niya. So 1 isopropyl, 2 methyl cyclohexane. Not 1 isopropyl, 6 hexyl. 6 methyl cyclohexane. Hindi yun yung name niya. Its name will be 1 isopropyl, 2 methyl cyclohexane. Okay? So ganun lang. Pwede nyo i-screenshot yan. Okay? So let's proceed with the next one. Okay? So we have this one, letter E. So for the letter E, our ring chain is ito. Ayan yung naka-ring natin, no? Okay? So, ilang carbons meron yung ring na yan? Bilangin natin. We have 1, 2, 3, 4, 5. No? 5 carbons for this ring. So, our parent chain will be named Cyclopentane. Okay? Cyclo, circular, naka-ring. Pent, because 5 carbons yung meron tayo, and ane, kasi puro single bonds lang naman, no? So, cyclopentane. Okay, so that's your parent. Then, for your substituent, you have this group here, no? So, ano kaya name niyan? So, ang name niyan is isobutyl. Okay, so if di pa rin kayo familiar, you just check this, this PowerPoint. Okay, so ano yung itsura ng isobutyl? This is your parent chain. Then you have your CH2, CH, then 2 CH3s, no? Attached to this carbon. Okay? CH3, CH3, ito yon, CH3, CH3. This is the CH, ayon. Then ito ay CH2, then your connection to the parent chain. Okay? So if you're not still familiar, if di nyo pa rin kabisado, that's okay. Just check this table na. Pero eventually, you will be familiar with all of them na makakabisado nyo rin yan in the future. Okay? So if hindi kayo familiar with the substituent, kung ano itsura niya, just refer to this slide na. Slide 13 sa PowerPoint natin. Okay? So yan, so that will be isobutyl. However, we only have one substituent. Isa lang yan. So, ano gagawin? So, since isa lang yung substituent natin, wala na tayong ilalagay na number. Okay? It doesn't matter kung saan siya nakalagay kasi isa lang naman siya. If ilagay mo yan dito, ang magiging substituent number niyan, yung locant number niyan would be 1. Pag nandito yan, 1 din yung kanyang locant number. Pag andito yan, 1 lang din. Okay? So, anywhere in this ring, ilagay mo yung isang substituent na magiging locant niya ay 1. So it doesn't matter, no? Kung anong carbon siya kumabit, no? Basta isa lang yung substituent, 1 yung kanyang number. No? Okay, so let's complete the name. So wala tayong locant number kasi isa lang yung substituent. So that will be isobutyl cyclopentane. Again, no dashes. Walang dashes so ganun lang. Let's have this one. Letter F. Dito na lang din. So for the last one, we have this ring. That is a 6-membered ring. So 6 carbon ring. 1, 2, 3, 4, 5, 6. So that will be our cyclohexane. Cyclohexane. Cyclo kasi naka-ring. Hex kasi 6 yung carbons. And ane because puro single bonds lang meron tayo. Okay? So after naming your parent chain, your cyclic ring, we have to name the substituents now. What are our substituents? So we have methyl, one methyl and another methyl. So its name will be dimethyl. Okay? Okay, so yan. That will be dimethyl. Dalawang CH3 Okay, so that's dimethyl. Here and doon. And this substituent, its name will be ethyl. Bakit naging ethyl yan? Kasi we have 2 carbons here. 2 carbons, ang prefix na gagamitin ay eth, no? So, di ba, meth, eth, prop, but, then Greek prefixes. Okay, so since 2 carbons to, we will use the prefix eth, no? And since this is a substituent, ang suffix niya ay il. So, ethyl. Okay, so yan. So let's check let's check their priorities, alphabetically. So who will come first? Is it the dimethyl or the ethyl? So meow. Gising na yung pusa. Okay, so ang mauna ay ethyl, not the dimethyl. Bakit? No? Sir, letter dito. Bakit hindi ito yung mauna? Kasi yung mga Greek prefixes such as di, tri, tetra, we do not count them. No? Hindi sila kasama sa pag-alphabetize. No? Do not consider them to be part of the chronological order nila. No? So, yun. So, hindi natin uunahin yung di. Hindi natin papansinin yan. No? So, M yung papansinin natin. Okay? So, yan. So, ethyl muna. This will come first, no? Before the dimethyl. So, I will give this locant number 1. 1 ethyl. Then, yung dimethyl natin, check natin yung possible names niya. No? Possible numbers niya. So, ito yung mga possible numbers ng ating dimethyl, no? Okay. So, if I number my rings clockwise, diba ganun yung clockwise, diba? Right to left, no? Clockwise. Kapag clockwise yung aking pag-number, this methyl will have a substituent 2, and this one will have a substituent number 4, no? So, 2, 4. If I number my ring in a clockwise hindi pala clockwise, counterclockwise fashion, kapag counterclockwise naman yan, yan, pag ganun. So, ang magiging number ng aking substituent will be 4 and 6, no? So, which of the two is better? Is it the 2, 4, yung clockwise, or the counterclockwise, 4, 6, no? So we will still choose kung sino yung lowest yung number combination. So it is always the lowest number combination, no? Nalalagyan natin ng na pipiliin natin, no? So hindi itong 4 and 6, rather we will choose 2 and 4 as the substituent numbers kasi yung lowest combination. Okay? So yun yung ating name ng substituent, 1-ethyl. This takes the number 1 kasi siya yung una alphabetically, no? The next is the bakit siya yung second alphabetically? Because yung di, this Greek prefix, hindi natin sinasama yan sa pag-alphabetize, no? Only the methyl, no? Okay, so 2 and 4 yung pinili natin rather than 4 and 6 because 2 and 4, ito yung lowest combination. Okay, then your parent is cyclohexane. So finally, let's arrange the names, no? I-arrange natin siya to have our complete name, no? So mauuna yung ethyl, no? Because alphabetical yung arrangement ng substituents. So this will be 1-ethyl 2,4 dash dimethyl cyclo kasya ba? Kasya. Hexane. So yan yung magiging name niya. 1-ethyl dash 2,4 dash dimethyl cyclohexane. Okay, keep in mind if dalawang number yung magkatabi, use a comma, no, to separate the numbers. Kasi kapag walang comma yan, baka 24 carbons yung isipin nila, no? So hindi ganun. And again, if letter and number yung magkatabi, either sa left or sa right yung letter ng number, no? So yun, you place a dash, no? 1-ethyl, L-2, 4-D. Okay, so may dashes kapag number and letter ang magkatabi. Pag parehas number, comma. Pag parehas letter, walang spaces. Okay, so ganyan yung complete name. Why do I reiterate, no, sa proper naming? Kasi pag kayo nag-quiz, most likely, nakalagay lang yung structure, tapos kayo magpapangalan, ito-type nyo siya. Okay, so yan. Para mas masaya. So, bawal spaces, no? As much as possible, i-lowercase lahat, no? Okay, so lowercase lang lahat, no? Ayan. Okay, so that's how we name our cyclohexanes. No? Punta naman tayo dito. Okay na yan. Ito muna tayo na. So, yan. So, yan yung naming ng ating tatlong examples here. No? So, let's proceed with the next part. Okay, so dito na tayo. So, conformation of alkanes. No? So, what is conformation? No? Kasi remember, our molecules are in 3D, no? And they follow certain arrangement, certain geometry based on the valence shell electron paired repulsion theory, the Vesper theory, no? So according to the Vesper theory for carbons ng alkanes, its geometry will be tetrahedral, no? Okay? And then since alkane yan, puro single bond yung meron tayo. Okay? So, ano yung mga possible na conformation ng ating alkanes? Okay, so let's have, for example, the butane here. Although, di naman natin to i-focus sa quiz, no? Dadaanan lang talaga natin. So, typically, this is the pattern, this is the drawing of your your butane, no? So, butane, 4 na carbons, CH3, CH2, CH2, CH3. Usually, it is drawn in a zigzag fashion, no? Okay, preserving the tetrahedral geometry, no, of your carbons. No? So, naka-tetrahedral shape yan. Each angle is around 109.5 degrees. No? However, since yan ay single bonds, no, puro single bond lang yan, your carbon atoms can rotate. Pwede umikot yung carbon atoms kasi single bond lang yan. So, pwede umikot-ikot yung carbon na yan. So, suppose I rotate this carbon by 120 degrees. Ganito yung magiging itsura niya. So, nandito siya sa baba, ngayon nandun siya sa taas. No? If you rotate this by another 60 degrees, so ganito yung magiging itsura niya. Parehas na sa taas. No? Okay. So, ano yung mangyayari? So, yun nga. So, your single bonds can rotate, no? And each rotation, may iba't ibang implication dyan, no? Okay. So, for example, we have this one. So, if we will focus on this bond, etong carbon-carbon bond na yan, daanan lang natin to saglit, ha? But if you want the full discussion here, andun yun sa lesson ko na Organic Chem, chapter 5, no? Yung nasa YouTube playlist natin. Panoorin nyo yan. May iyak na lang kayo. Kasi mukha lang siyang simple pero mahirap to, no? Anyway, so for example, this is your butane. Ito yung focus natin, itong dalawang carbon in the middle. I can rotate this bond, no? Kasi single bond yan. So single bonds can rotate, no? So pwede siya umikot-ikot. So pwede yung CH3 mapunta doon and another rotation mapupunta siya doon sa kabila. So what will be the implication? Okay, ang implication niyan is ganito. If yung dalawang CH3s mo magkatabi, there will be what's called the crowding, no? Magiging crowded yung conformation mo. So, ano meaning kapag crowded? Kapag crowded yung ating structure, that means your electrons are repulsing. Kasi ano meron sa mga atoms na yan, 'di ba? Electrons 'yan. Pag pinagtabi-tabi mo yung electrons, there will be repulsion. Yun nga yung mismong concept ng VSEPR, 'di ba? Valence shell electron pair repulsion theory, no? So ibig sabihin, if your atoms are together in a certain conformation, ano mangyayari? Magkakaroon ng repulsion. Hence, the molecule will not be stable. So, hindi siya magiging stable if your groups are together, no? So, kunwari, yan, parehas silang magkasama. Okay, so may electrons dito, may electrons doon. So, what will happen? There will be repulsion. Same as this one, no? So, magkakaroon sila ng repulsion. However, for this one, etong naka-zigzag lang, wherein your CH3s are separated, walang repulsion dyan. Least crowded, no? Bakit? Kasi itong CH3 mo, wala siyang natatamaan sa kabila. This CH3, wala siya natatamaan din sa kabila, no? So, ibig sabihin, ito yung pinaka least crowded conformation. So, ibig sabihin nun, wala siyang natatamaan na CH3s and other groups sa kabila, no? Okay? So, kapag ganun, ibig sabihin nun, your molecule is stable. Okay? So, that is the least crowded conformation. This is the most stable conformation for for butane. No? Okay? So, kaya usually, draw natin yun as zigzag. No? Kaya nakaganyan talaga yan. Kasi yun nga. Ito yung least crowded. Ibig sabihin, more stable. Bakit more stable? Kasi nga, walang repulsion. Okay? However, these two, may repulsion dyan, no? Because your CH3s are close together, no? Okay? So, ibig sabihin, we will not observe this most of the time kasi unstable siya. Okay? Because of the repulsion. Rather, we will observe this, no? Mostly, ito yung ma-observe natin. For your cyclic compounds, no? Yung ating mga cyclic compounds, meron din silang conformation. Okay? Remember, your carbons want to be in a tetrahedral shape, no? So, gusto nila naka-tetrahedral sila. So, as much as possible, your carbon atoms will arrange themselves accordingly to follow the tetrahedral geometry, no? So, this is the cyclopentane. Ito yung itsura niya. So, para siyang aso, no? So, ito yung paa. Kaso dalawa yung buntot ng aso na scary. Okay. So, dalawang katawan ng aso tapos isa yung ulo. Ha? Ano na pala to? May sa demonyo na siya. Okay. So ito, para siyang aso na lang, imagine nyo. So this is the body, ito yung paa, ito yung buntot, dalawa nga lang yung buntot, then ito yung ulo niya, no? So this is the conformation for cyclopentane. Ito yung mismong 3D structure of the cyclopentane that is found in nature. So that is called an envelope conformation. Bakit? Imagine that, etong carbon na to, pwede mo yan i-flip dito. Just like your envelope, di ba? Di ba yung envelope flat yan? Tapos pag tinakip mo yung triangle sa taas, you have your envelope, di ba? Parang ganito yan eh. Ay, bakit siya naging envelope, no? So ito, square yan. Square yan, 1, 2, 3, 4. Square yan. Then, itong nasa taas, parang envelope yan, no? Teka lang. Kapag ganyan yan eh. So, kapag flinip mo yung carbon dito sa dulo, yan, envelope, diba? O, creative yung mga chemist ninyo, no? Naisip nila yung mga ganyang bagay, no? So, yan. So, ang name niyan ay envelope conformation. This is the stable conformation of your cyclopentane. Of course, marami pa tong marami pa yung versions, no? Although we will not discuss them. If you want to check them out, punta lang kayo sa OrgChem Chapter 5 sa playlist natin, no? Yung 3 hours na discussion doon. Actually, 6 hours yan in total, no? So, yan lang. So, yan. Pag tinanong kayo, what is the most stable conformation of cyclopentane? Automatically, envelope conformation ang sagot natin. Okay? So, yan. So, let's proceed with the next one. Cyclohexane as the other abundant cyclic compound. So, the most stable conformation of your cyclohexane would be the chair conformation. Ano itsura niyan? Para yung messenger, no? Buksan niyo yung cellphone niyo. Tignan niyo yung nasa messenger. 'Di ba? Parang may chair confirmation ka doon, no? Sige, pakita ko sa inyo. O, ito yung messenger. Ayan. 'Di ba? Ayun. Hindi ko ma-zoom kasi. Wala naman zoom dito. Basta 'yan, nakikita niyo may 6 edges yung logo ninyo ng messenger, no? Okay, so yung 6 edges na yon, that is in a chair conformation, no? Okay, so yun lang. So, ganun yung itsura niyan. So, ito yung chair. Paano yan naging chair, no? Ganito lang. Imagine nyo, ito yung upuan. Ayan yung upuan. Ito yung backrest. Ayan yung backrest. Tapos, ito yung paanan, no? So, yan, parang nakaupo ka dyan. Siyempre, pangit drawing ko. So, ito yung nasa likod ng upuan. As ito yung sa paanan, no? Tapos ito yung upuan mo. Kaya chair yung tawag dyan nila, no? Okay. So, this is the skeletal drawing for your chair conformation. So, mapapansin nyo, alternating yung carbons dyan. Meron sa taas, meron sa baba, meron sa taas, tapos dito naman sa baba, meron sa baba, taas, baba. So, they are alternating, no? And if you draw its 3D structure, ito yung actual model niya, no? So, yan. So, your carbon sa taas, may dalawang carbon sa baba, dalawang carbon sa taas, isang carbon sa baba, no? So, alternating sila. All of the carbons are in a tetrahedral formation, no? Tetrahedral geometry. Okay? So, if you view it from above, maging maging cyclohexane yung kanyang drawing, no? Pag naka-top view yan, tinignan mo sa taas yung molecule, naka-hexagon siya. However, kapag side view, makikita mo yung kanyang chair conformation. Okay? So, ganun. So, medyo 3D lang yung imagination dapat natin, no? So, again, for cyclopentane, its stable conformation is an envelope conformation. Okay? So, pa-envelope siya. Ito yung reason kung bakit tawag dyan ay envelope. You have your carbons here, 1, 2, 3, 4. Ito yun, 1, 2, 3, 4. Then your carbon on the top, Imagine that as as a flap, no? Yung flap, pag clinose mo, you have your um, envelope, no? So, yan. Parang envelope lang na binuksan mo, no? Tapos takpan mo. So, yan. Okay, so that's your cyclopentane. That is the envelope conformation. And for cyclohexane, ano meron tayo? You have your chair conformation. So, ano itsura ng chair conformation? Tingin lang kayo sa messenger nyo. Kung ano yung drawing ng logo sa messenger, yun yung chair conformation. Okay? So, ganun lang. Kung gusto nyo talaga makita, di sige. Messenger logo. Okay, so ayan, para makita natin. Ito yung old logo. Pangit na ngayon yung logo niya yun. Integrate daw kasi nila Instagram eh. Okay, so ito yung chair conformation. Ito yung nasa, baliktad naman to, no? Ito yung backrest, ito yung upuan, dito yung paa, no? Up, down, up, down. Okay, so ganun yung pattern ng carbons, no? So, ganun din dito, no? Down, up, no? Okay, so yun. If makalimutan nyo yung drawing ng chair conformation, tingin lang sa messenger, no? Okay, so that's the conformation for your cyclohexane. Okay, ayaw na mag full screen. Okay, so in a chair conformation, you have 6 carbon-hydrogen bonds that are axial and equatorial. So ano meaning niyan? Okay, so if we check this carbon, mapapansin nyo, some hydrogen bonds are pointed upwards, no? So may naka-point pataas and may naka-point pababa, no? Then some of the carbon-hydrogen bonds here are pointed on the equator, no? Nakapaside yung carbon-hydrogen bond, no? So specify natin kung ano yung mga yon, no? So yung mga carbon-hydrogen bond that are pointed on the axis, top and bottom, no? So ito yon, no? So yan yung mga carbon-hydrogen bond na naka-point upwards and downwards. Pag upwards and downwards yung point, tawag doon ay axial. So naka-axial kapag pataas and pababa yung point ng CH, no? Pag nakapa-side view naman, for example, itong mga to, yan. So yan, mga naka-side view sila. So we call them the equatorial, no? So how many axial carbon-hydrogen bonds do we have here? Ilang axial? 1, 2, 3, 4, 5, 6, no? Tatlo sa taas, tatlo sa baba, no? So you have your 6 axial CH bonds, and you also have another 6 equatorial CH bonds. Sila yung mga na-point sa left side. So ito nasa left, 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 right, 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 no? Basta naka-point sa side na. Okay? So yun lang. So that is your cyclohexane, no? That's your conformation kapag yan yung yan yung pointing ng ating carbon-hydrogen bonds if you have cyclohexane na naka-chair conformation. Okay? So we can represent, no? Although sa biochemistry nyo na magagamit to ng tuluyan, no? Okay? So if our hydrogens are equatorial, nakapa-side view yung angle natin. However, if yan ay naka-axial, naka-point upwards and downwards sila, no? So you have to be familiar lang. Pag naka-up, yan ay axial. Kapag nakapa-side view, yung angle, yan ay equatorial, no? Okay? Axial, equatorial. So hindi na natin discuss to ng malalim, ha? Okay. So yan. So whenever we have substituents for our cyclic compounds, usually the most stable conformation for substituted cyclohexane is the equatorial version rather than the axial version. Okay? So na rin nakita nyo sa quiz, no? Ano yung stable conformation ng mono-substituted cyclohexane? cyclohexane. So, meaning na may isang substituent ka, no? So, ano daw yung most stable? The answer will be the equatorial. Bakit, no? So, let's imagine this. So, this is your equatorial methyl group. Nakapa-side view yung itong CH3 group na to. So, as you can see, wala siyang effect sa ibang hydrogen atoms, no? Kumbaga, hindi siya tumatama, no? Hindi siya nagkakaroon ng repulsion with other atoms here. Kasi it occupies a different space on the side, no? Okay? So, ibig sabihin nun, kapag equatorial, it will not induce repulsion. So, hindi siya magre-repel with other atoms of your cyclohexane, no? Ano naman kaya mangyayari kapag equatorial yan? I mean axial. Okay. Kapag axial, what will happen? Ito yung CH3 mo. Ano mangyayari? May natatamaan siyang hydrogens, no? So, kumbaga, there is a steric hindrance, no? Ibig sabihin mayroong repulsion. So, kapag naka-axial yan, yung substituent mo, may tinatamaan siyang dalawang atoms ng iyong cyclohexane. That's why equatorial, no, yung mga equatorial sila ay mas stable compared to the axial. Bakit? For axial, may natatamaan na ibang atoms, no? Okay, so yung CH3 tinatamaan niya yung dalawang H na naka-point din upwards, no? However, if that is equatorial, your CH3 will not bump against other atoms here kasi it will occupy another region sa end ng molecule, no? So, dun siya sa dulo nakakabit lang. Unlike ito na may binubunggo pa siya sa taas, no, na hydrogen atoms, no? So, that's the reason why we say that cyclohexanes that have an equatorial substituent is more stable than the axial substituent, na? So, yun lang naman kailangan i-keep in mind nyo. Then now, we will proceed with the cis and trans isomerism. No? So, cis and trans isomers, again, what are isomers? They are the same compound, no? They have the same formula. They have the same formula, pero different yung compounds, no? Kamali yung sinabi ko. Okay? So, pag isomer, same formula, however, different yung compounds natin. Okay. So, what is a cis and trans isomer, no? So, when you say cis, ito ay Latin word for same side, no? Yung trans, ito ay Latin word for the opposite sides, no? Parang sa gender lang yan, no? Cisgender, transgender, no? Kapag cisgender, ano meaning ng cisgender? Kung ano yung identity mo, yun na yung iyong sexuality, no? Kung ano yung iyong biological appearance, yun yung iyong sexuality, no? So, ibig sabihin on the same side ka sa sa kung ano man meron ka sa katawan mo, no? So, yung cisgender yan. Pag trans naman, you identify as the other gender, di ba? So, ganun din dito sa molecule, no? So, if same side yung iyong substituent yung tinutukoy natin dito, hindi gender. Walang gender yung mga molecules na yan. Okay? So, if they are on the same side, yung substituent natin nasa iisang side, we call them the cis isomer. Pag sila ay naman nasa opposite sides ng molecule, we call them the trans isomer, no? So, let's have these two cycloalkanes with substituents, no? So, for example, we have this one. Okay, so mapapansin mo, yung CH3s, parehas silang nasa baba, no? So, kapag parehas nasa baba ang iyong substituent or parehas silang nasa taas, we call them the cis isomer. Okay? So, yung naming niyan, ganun pa rin naman, cyclopentane kasi 5 carbons yan. 1,2-dimethyl yung substituent kasi you have 2 methyl na substituent. So, dimethyl yon. Ang numbering yan ay 1 and 2. So, that's 1,2-dimethyl cyclopentane. However, you have to attach the word cis. Bakit, no? Kasi, Another version of this molecule is yung iyong CH3 ay nasa opposite side. So, kumbaga, ito yung side mo, no, na ito yung baseline. If parehas silang nasa isang side ng molecule, we call them the cis isomer. However, if ito nasa baba, yung isa nasa taas, we will call it the trans isomer. Okay? So, to name it, ganun pa rin, 1,2-dimethyl cyclopentane, same pa rin naman, no? However, due to the difference kung nasaan ng iyong substituent, ito nasa baba, parehas, ito nasa baba isa, nasa taas isa, magkaibang compound sila, no? As a result of that, no? Okay? So, yan, ito ay cis isomer, parehas nasa baba yung substituent mo. And then you have your trans isomer, nasa opposite side ang iyong substituents. Okay? Another way to represent the cis and trans isomerism is by using the wedge and the dashed arrow. Okay, so ano yung mga wedge and dashed arrow? Okay, so kapag yan ay wedge, yan ay represented as two solid lines na solid yung iyong bond, no? So makapal yung bond, no? So ito yung wedge, no? Ay, teka lang. So ito yung wedge mo. Tapos ito yung dash. Okay. Solid wedge and the dashed wedges. Solid. So ano yan? So that is still a bond. Bond pa rin yan with carbon. However, it tells us about the 3D orientation. No? If yan ay naka-wedge, that means it is pointing towards you. Kunwari, naka-paper yan, nasa papel yan. Kunwari, ito yung paper, no? Pag wedge yan, nakatutok yan sa mata mo. So, these CH3s are pointed towards your face. No? Nakatutok yan sa mata mo, no? So, since parehas silang pointing towards you, that means they are cis isomer. Okay? So, kapag solid wedge, they are pointing towards you. So, ayan yung flat na paper, it is pointing towards your eyes. Kapag dashed naman, it means na nasa likod ng paper yung substituent. Okay? It is not pointing towards you, rather pointing away from you. Nasa likod siya ng paper. So, for example, ito ay solid wedge. So, this is pointing to you. Itong CH3 na to, this is dashed. So that means it is pointing away from you. Nasa likod siya ng paper. Ito, nasa harap ng papel. Okay? So that's one way to imagine that. So kapag ang iyong substituents, they are both pointing towards you, yun ay cis. Pag sila ay on the opposite direction, yung isa ay naka-solid, yung isa ay naka-dash, so, ibig sabihin nun, trans yun. Kasi yung isa nasa taas, yun yung solid, yung isa nasa baba, yun yung dash. Okay? One question dito is, sir, paano po kaya kapag ito ay parehas na dash, no? Nare, dash to, tapos ito, dash yan. Draw natin. Sir, paano po kaya kapag ganyan? Parehas naka-dash. Is that a cis or trans? Ganito lang. Imagine mo, kapag magkasama sila naka-point sa'yo or naka-point palayo sa'yo, cis yun. No? So, ito parehas sila naka-point towards your eyes. So, that means it is a cis isomer. Ito naman, parehas silang pointing away from you. So, ibig sabihin, magkasama pa rin sila sa isang side. Nasa kabila nga lang, no? Ayaw nila sa'yo. No? Kaya naka-away sila sa'yo, naka-dashed sila. No? So, ito ay cis isomer pa rin. Okay? The only difference is that ito parehas silang pointing towards you. Ito naman, parehas silang pointing away from you. However, since they are on the same side pa rin, so cis isomer pa rin, ayan. No? Another version of this trans isomer is yung magkabaliktad naman sila. No? Ay, wait lang. So another version of that molecule is ito. Oopsie. Ano yon? Ito. Okay, so ito yung isa pang version yan. Wherein, ito naman, yung nasa harap, itong nasa left, it is pointing towards you. Itong nasa right, this is pointing away from you. So this is another version of the trans isomer. It doesn't matter kung sino yung nasa front, sino yung nasa back. As long as magka-opposite sila ng direction, trans isomer yan. Pag same side, that is a cis isomer. Okay? So to practice on that, ay teka lang, bago tayo pumunta dyan. Ito na nga yung sinasabi ko. Teka lang, sabi ko na pala itong slide na to. So ano lang meron dito sa slide na to? Ayun nga, so kapag yung isa naka-dash, yung isa naka-wedge, solid wedge, trans yun. Pag parehas sila naka-dash or parehas sila naka-wedge, yun ay cis, no? So yan, parehas sila na sa baba. So this is one way to represent that. Parehas na sa baba yung CH3. So yan ay cis. Pag sila ay magka-opposite ng direction, naka-trans yan, no? So yun lang. Ayun lang. So, practice na muna tayo. Malapit na tayo matapos sa alkanes. Buti naman. So, let's have this. No? Letter G. Trans 1,3-dimethyl cyclopentane. Ano daw kaya yung drawing niyan? No? Okay. So, you draw your parent chain. The parent chain is always indicated at the last part of the name. No? So, cyclopentane. So, draw natin yan. Yan. Then we have trans 1,3-dimethyl. It doesn't matter kung saan mo gusto ilagay yung unang methyl. No? Kunwari, gusto ko nandito yung methyl. Ayan. Ganyan ko na lang. Tapos, yan. This will be my carbon 1. Then, ano din mag-count ng 1, 2, 3. Pwedeng dito yung 1, 2, 3. Ako, I prefer dito sa right side. No? Pero pwede rin sa left side, ha? Hindi porket di ko ginawa yun sa other side is mali yun. No? Pwede rin dito ka maglagay ng isa pang methyl. Okay? I just want it to be placed here. No? So gusto ko nandun eh. Pwede rin dito ha. Okay? So 1, 3 pa rin yan. However, sabi dito, sila ay naka-trans. No? So that means one of them is pointing upwards, the other is pointing downwards. So ano yung drawing nun? O you assign kung sino yung nasa taas. Kunwari gusto ko yung methyl sa carbon 1 ay nasa taas. So I will indicate that with a wedge, with a solid wedge. No? Paano mag-drawing ng solid wedge? Gawa ka lang ng triangle, tas i-fill mo lang. Okay? So, solid wedge yan. Then, paano yung dash? Triangle yan na putol-putol. Basically, tignan mo na lang yung Wi-Fi symbol mo sa cellphone. Ganon yung itsura niya. Okay? So, since this is trans, no, yung isa ay nasa taas, it is indicated by the solid wedge bond. So, that means yung isa pang methyl dapat ay naka-dashed, no? Naka-dashed siya. Okay? Ayun, pangit yung drawing ko ulit. Basta yan. So, yan. So, ito ay solid. Ito ay dashed. This is pointing upwards. This is pointing downwards. Okay, so trans yan. No? This is solid wedge. This is the dashed wedge. No? Another way to draw that, no? Draw pa natin yung isang version yan, is that, itong nasa taas yung nakababa, itong carbon 1 yung naka-point downwards, tapos andito naman yung, andito naman yung solid, no? Na wedge, no? Andito yung dash, andito yung solid. That means this methyl group is pointing downwards. This methyl group is now pointing upwards. So they are trans pa rin, no? Isa nasa baba, yung isa nasa taas. So trans isomer yan. Okay, so ganun lang. It's just a matter of placing wedge and dashes, no? Okay. So next one, we have this one. So cis 1,2-diethyl cyclobutane. Draw your parent chain, cyclobutane, 4 na carbons. So paano mo i-draw yun as a ring? Yun ay square. Yan yung cyclobutane. Pag cyclopropane, triangle. Cyclobutane, square. Cyclopentane, yan ay pentagon. Then cyclohexane, yun ay hexagon. Kumbaga, bumabalik tayo sa ating memories ng childhood, no? Ginagawa natin to nung kinder, gagawin din uli natin ngayon, no? Ganun lang. Sabi ko nga kasi may pamangkin ako na bata. Turuan ko siya ng Lewis structure agad, no? Pag nag 1 year old na siya or 2 years old. Pwede na yun. Ako, nag-aaral ako 3 years old So, kaya na niya maintindihan yan siguro. Kasi connect the dots lang naman yan, di ba? Di ba? Kapag may dot, connect the dots. No? Tatry ko rin. Kung matutunan niya, edi may chemist na panibago sa bahay. Anyway, so this is our cyclobutane. Ayan, 1, 2, 3, 4. 4 carbons. 1, 2. So, ibig sabihin, andito yung isang ethyl. Tapos, andun yung isang ethyl. May question sa akin last time na nag-message sa akin. Sabi, Sir, kailangan po ba naka-bend? Opo. Kasi kapag hindi yan naka-bend, kapag nakapag-ganon yan, ano meaning yan? CH3 lang yan. Na? Kaya nakaganyan lang. CH3 lang yan. Kasi isang point lang yan. Kapag gusto mo ng CH2, CH3, then you have to indicate yung dalawang points sa line na yon. Ito yung isa pa. Kailangan may bend, no? So, yan. So, paano yan? We have to indicate na sila ay parehas na cis. No? Okay. So, in cases like this, no, ganito lang gagawin nyo. Yung bond to this carbon lang, yung lalagyan nyo ng wedge or dashes. No? Solid or dashed wedges. No? So, ibig sabihin yan, kung gusto ko yan ay maging solid, no? Solid na wedge, ganito lang. So, ganun lang. Lalagyan ko lang ng ganun. So, hindi necessarily lahat yan ay naka-solid, ha? Yung isa lang, no? This bond to that carbon lang, yung iyong iso-solid, no? So, that means this group is pointing upwards na. The rest, hindi mo na kailangan i-solid, no? Isang beses ka lang magso-solid. At isang beses ka lang din mag-dash. Okay? Baka kasi mamaya, dash nyo lahat, no? Or baka i-solid nyo lahat, no? Hindi ganun. Okay? So, yan. So, ano meaning niyan? Ito carbon na yan, tapos ito carbon yan. Carbon to, carbon yan. Carbon yan, carbon yan. Carbon ito, carbon din yan. Okay? So, this is our cis 1,2-diethyl cyclobutane. Cyclobutane, square. Diethyl, you have your 2 CH2 CH3s on carbon 1 and 2. Cis, ibig sabihin nun, they should be pointing upwards or downwards at the same time. So, ito ay parehas naka-cis, no? Parehas silang pointing upwards. So, I indicated that with a solid wedge bond, no? So, isang beses ka lang maglalagay ng solid wedge. Kasi mamaya, kapag nilahat mo yan, wala na, ang confusing na. Confusing na yung drawing kapag ganun na. So, isang beses ka lang maglalagay ng solid wedge or ng dash, no? And of course, you still have to you still have to show the angle, no? For example, dito. Pakita mo na itong bond na to. This is different angle than this one, no? Magkaibang angle sila, no? So, yan. Ito nakapag-ganon, ito nakapababa, no? So, ibig sabihin yun, you have your carbon here and another carbon there. Carbon here, carbon there. Okay? So, ganun lang. Okay? So, with that, we're done with di pa tapos tayo sa alkanes. Pero malapit na tayo matapos talaga. Okay? So, we are done naming alkanes and cycloalkanes na. So, ngayon naman, let's proceed with the physical properties of your alkanes. No? So, what do we know about alkanes? No? What we know about alkanes is that the bonds are nonpolar. Bakit nonpolar yung bonds? No? Because the electronegativity scale is around 0.4, no? Which is on the nonpolar side. No? So, that means our alkanes are nonpolar. Ibig sabihin, anong interaction pwede nila gawin? They can only possess or they can only do London dispersion forces. Ano yung concept sa London dispersion forces ninyo sa lecture? So, according to the London dispersion forces, the higher the London dispersion forces, the higher the intermolecular forces. No? Ibig sabihin yan, pag maraming London dispersion forces, the boiling point and the melting point will be high. No? So, yan. Ano pala yung concept ng London dispersion? No? When we say London dispersion forces, we are just pertaining to the number of electrons, no? Or number of atoms. No? So, the more electrons or the more atoms you have, no, the higher the London force, hence the higher the intermolecular force. That means for your alkanes, the longer the chain of your alkane, the higher its interaction will be, the higher its intermolecular forces will be. Ibig sabihin nun, the boiling point will increase as you increase the carbon chain. So let's have this for example. So this is our alkanes, no? Ito yung kanilang atomic masses, no? And ito yung kanilang melting and boiling point, no? As well as their density. Okay, so let's observe, no? According to the London dispersion forces, the higher the number of electrons, the higher the number of atoms, that means your molecule will have more tendency for it to be temporary dipole, no? So, yun yung sabi sa lecture nyo. So, kapag maraming electrons, the more susceptible they are to external electric forces. So, that means you will have more temporary dipoles. No? Kung naaalala nyo pa. Okay, so ganun din yung concept dito. The longer your carbon chain, the higher your melting and boiling point will be. So, let's have, for example, methane. The melting point of methane is negative 182 degrees Celsius. Its boiling point is negative 164 degrees Celsius. However, if we increase the number of carbon atoms, for example, octane, so from negative 182 na melting point, it is now negative 57 degrees Celsius. No? Yung boiling point naman tignan natin. Okay? So for methane, that is negative 164 degrees Celsius. For octane, that is 126 degrees Celsius. Imagine, ganito. Which of them will exist as liquid? Is it the methane or the octane? At 25 degrees Celsius, sino yung liquid? Is it the methane or the octane? So the answer would be octane. Ito yung magiging liquid natin. Bakit? Kasi imagine itong boiling point ng methane. Ano yung boiling point niya? Negative 164. Ano yung temperature natin? 25. So that means methane already boiled off at 164 degrees Celsius, negative 164 degrees Celsius. Nag-boil off na siya nun. Ibig sabihin, it now exists as gas, no? Temperature higher than negative 164 degrees Celsius. Gas na yan. Okay? So, kaya nga at 25 degrees Celsius, no? Gas yung methane sa ating mga septic tank, no? So, nakagas na yon. Hindi na siya liquid, no? However, for octane, ito yung nasa gasolina. Kailan siya magbo-boil off? 126 degrees Celsius, no? So that means this will exist as liquid, no? Okay? So liquid 'yan. Kaya ito yung ginagamit sa gasolina kasi liquid, no? Okay? Tapos mataas din yung boiling point niya. Okay? So ganun lang yung concept, no? So starting kay butane, pwede ka na magka-liquid, no? Pero ito mga gas na 'yan. Okay? Tapos ito mga liquid na 'yan. Okay? Kasi ang concept ng intermolecular forces, the stronger the intermolecular forces, the more liquid or the more solid it becomes, no? From gas, no? So ito mababa yung intermolecular forces dyan, kaya gases yan. However, if you increase the number of atoms, the intermolecular forces, kapag tumaas yan due to London force, tataas yung boiling point. So magiging liquid sila. Then eventually, pwedeng maging solid yan. One example of a solid alkane is your waxes. Yung nasa kandila. No? Alkanes lang yon. Ang tawag sa kanila ay paraffin. No? So, puro alkane lang yon pero solid sila. Bakit? Kasi yung kanilang chain ng carbon ay super duper haba. No? So, mahaba yung carbon chain na yon. So, solid sila. However, if you decrease the number of carbon chain of your alkanes, ano nangyayari? Bumababa yung boiling point, hence they become liquid, they become gas, no? At certain points, no? So, yun lang yung concept, no? Basically, the higher the number of electrons, the higher number of atoms, the higher London dispersion forces, and the higher intermolecular force you will have, no? Ibig sabihin, mas mataas yung kanilang melting point and the boiling point. Okay? Another way, no, to check yung kanilang boiling point, no, or melting point ng ating alkanes is because of their isomerism, no. So alkanes that are constitutional isomers, ano meaning niyan? Alkanes that are constitutional isomers are different compounds and have different physical and chemical properties. No? So despite them having the same formula, because they are isomers, they will have different chemical and physical properties. No? Kaya magkaibang compound yon kahit same formula yon. So let's have a look at these two isomers of hexane. So we have here the normal hexane, which is a chain. Ano yung drawing niyan? Ang hexane ay ganito. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Ang 2,2-dimethyl butane. Ano itsura niyan? Okay. So this is one version. This is one isomer of your hexane. Let's check at the boiling point. What happened? Ano nangyari? Nung nagkakaroon ka ng substituent sa iyong isomer, the more substituent you have, what happens? The boiling point decreases. Ano meaning nun? Bumababa yung intermolecular forces of attraction. Ibig sabihin nun, if you have substituents, the intermolecular forces decreases. Bakit? No? Ito. Because of the surface area. Okay, so ano meron sa surface area? The more flat yung molecule mo, pag mahaba yung molecule mo, ibig sabihin mas flat yan. Ibig sabihin yan, it will have a big surface area, no? It will cover a larger area. For example, ano yung surface area niyan? Ito. Yan. Yan yung surface area niya. Ibig sabihin, mas malaki yung mas malaki yung kanyang makakapitan with the other molecules, no? Mas marami siyang kakapitan sa other molecules kasi mahaba siya, no? Okay, so maraming pwedeng kumabit sa kanya. So ibig sabihin nun, the more chances for the London forces to occur. Okay? However, if we have a small surface area because of the branching, because of your substituent, since bumababa yung iyong surface area, that means your London dispersion forces decrease as well. Bakit? Kasi onti lang yung kakabitan ng other molecules sa molecule mo compared to the long chain, no? Ito mahaba yung pwede kabitan, no? Maraming pwede kumabit sa kanya. However, kapag mababa yung kanyang surface area, onti lang yung pwedeng kabitan sa kanya. Onti lang yung space na pwede. So that will result to a decrease in the London dispersion forces. So as the London dispersion forces decrease, your boiling point and the melting point decreases, no? Okay? So we can say that for a straight chain, yung straight na zigzag, yun ay may pinakamataas na London dispersion forces because of the surface area. However, if you have branching, if you have substituents, bumababa yung surface area. Okay? So the more branching, the lower your boiling point, no? Okay? So yun lang. Sulit ko na nga. More branching or more substituent, the lower the boiling point, the melting point, no? The lower your intermolecular forces, no? Okay? Lang, mas maraming branch, mas maraming substituent, bababa ang intermolecular forces. As a result, bababa ang boiling point and melting point. Ano yung reason? Surface area. Okay? So yan. Kapag flat yung molecule, malaki yung surface area niya. Pag naka-branch yung molecule, kumpul-kumpul sila, maliit lang yung surface area nila. Okay? So yan. Another property of your alkanes is this one, the solubility. Ano yung concept ng solubility? Like dissolves like, no? Ibig sabihin nun, if yan ay polar, it will dissolve another polar molecule. If yan ay non-polar, it will not dissolve a polar molecule. No? So, ano ba yung alkanes natin? Our alkanes are non-polar. Bakit sila non-polar? Because the hydrogen-carbon bond is 0.4 in electronegativity difference. Ibig sabihin nun, non-polar yung bonds na yon, di ba? So, yan. That's why mapapansin nyo sa kandila, if patakan nyo yun ng tubig, what will happen? Magfo-fall off lang yung tubig, di ba? Hindi siya ma-absorb ng kandila. Because your kandila is an alkane. Alkane yung kandila eh. At yung alkanes ay non-polar. Okay? So kaya, kapag nilagay mo yung tubig doon, hindi niya ina-absorb yun. Tutulo lang yung tubig doon. Another example is yung mantika, pati yung tubig. No? A small portion of mantika is alkane. Sa gasolina, ganun din, di ba? Gasolina, yung octane. Pag yung tubig, nilagyan mo ng gasolina, what happens? Hindi sila nagbe-mix. They separate into layers, no? So, naghihiwalay sila into layers. Bakit? Kasi nga, hindi sila like. So, they will not dissolve each other. Okay? So, kailangan for your alkane to be dissolved, no? Para siya ay ma-dissolve, kailangan non-polar din yung iyong gagamitin na material. Hindi pwedeng tubig, no? That's why they say, no, kapag kunwari may sunog, no, involving gasoline, wag mo bubuhusan ng tubig. Bakit? Kasi yung gasoline, it will not mix with water. What will happen? Kunwari, nasusunog na yung gasoline. Wag mo bubuhusan ng tubig. Bakit? Kakalat lalo yan. Because of this concept, the like dissolves like. Since water and the gasoline, yung ating octane for example, hindi sila magmimix. So they will just separate. So continue pa rin yung apoy dyan. So, ano gagawin mo kapag ganon? Kunwari may nasusunog, tas may gasolina. Ang pwede mo gawin, kuha ka ng tela, basain mo yung tela, itakip mo sa apoy. Okay? So, yun. Para makover yung entire surface, no? Kasi kapag binuhusan mo ng tubig, kakalat lang yan, no? Okay? So, ganun lang. Yun lang yung mga natutunan ko sa NSTP, no? Okay? So, that can be explained by chemistry naman, no? So, yun yung mga tinuturo sa atin sa inyong CWATS, no? NSTP. So, keep that in mind, no? So, may chemistry explanation kung bakit ganun. Okay? Kung wala naman kayong tela na pwede i-cover sa apoy, edi gamit kayo ng fire extinguisher, no? Kaya nga kung mapapansin nyo, if there are chemical fires such as yung sa gasolina, gumagamit yung bombero ng no, instead of water, foam na retardant yung ginagamit nila, 'di ba? Yung kulay basta yung parang foam na nilalabas ng fire truck. Yun yung reason kung bakit na. Yung foam na yon that is able to to absorb the alkanes, no, that are burning, yung mga non-polar compounds, no. Kaya ganun. Share ko lang. Ayun lang. So yan yung kanyang physical properties. Solubility like dissolves like alkane is non-polar, so it will never be dissolved in water. So hindi sila maghahalo, they will separate, no. So if you want to dissolve your alkanes, edi i-dissolve mo siya sa iba pang alkanes, no. For example, yung gasolina, pati yung kandila. Pwede mo i-mix yun, no? Okay, so ganun lang. Ano pa? Density naman. So usually, the density of our alkanes is less than the water. Mas less siya sa water, kaya it will float sa tubig, no? Kaya ngayon yung sinasabi ko uli sa gasolina. Pag binuhusan mo yan ng tubig, kakalat yan. Lulutang yan sa tubig, no? So, wala din, effect, no? Okay. So, our alkanes are generally less dense than water. So, they will float, no? For example, yung kandila, no? Small portions of kandila, ilagay mo yun sa tubig, magfo-float yan, no? Yung gasolina, ilagay mo sa tubig, float yan. Okay? So, yun lang. And last one, we have the reactions. Patapos na tayo today. Thank you, Lord. Okay, so let's have the reaction of our alkanes. No? Dalawa lang naman yan. Okay? So, dalawa lang para basic lang. Okay? So, let's discuss the first reaction. The first reaction of our alkane is what's called the oxidation reaction. AKA the combustion reaction. Okay? So, naalala nyo pa ba yung combustion sa lecture nyo? Ito uli yan. No? So, when we have combustion of our alkanes, it basically means that your alkane will react with enough oxygen atoms to form carbon dioxide, water, and heat. No? Okay? So, yan lang. Yan na yan. Alam nyo na to sa lecture. Binabalance nyo na to, di ba? So, this is one reaction of your alkane. We call that the combustion reaction. You have your alkane here, the CH compounds reacting with oxygen to form carbon dioxide and water. Okay? So, hindi na natin dadaanan to masyado kasi basic na to. Balancing equation lang yan, no? So, ito yung format. You have your alkane, the CH compounds plus oxygen gas forming CO2 and H2O. Ito, heat yan. Ibig sabihin may init, no? Totoo naman, di ba? Kapag nagliliyab ka ng organic matter, for example, gasoline, mainit, di ba? So, may energy dong nilagay. However, ang focus lang natin is this part lang. Okay. So, yan. Ito lang yung focus natin. Though we can compute for this, di na natin gagawin. Ayun lang ha. So, these are your alkanes. They will combust accordingly. Kailangan may oxygen to form CO2 and H2O. Balik ulit tayo sa kwento ng apoy. No? So, one way to eliminate fire para huminto yung apoy is i-deprive mo ang fire ng oxygen. Huwag mo siya bigyan ng oxygen. Bakit? Kasi according to this equation, the combustion reaction will happen with oxygen. Okay? So, may apoy kay. No? So, this serves as your fuel. This serves as your oxidant. No? So fuel plus oxidant equals fire, no? So para huminto yung apoy, bawas tanggalan mo ng oxygen. One example is the experiment kung saan yung kandila nasa loob ng bottle, niliyaban nila. Pag tinakpan mo yung bote, what will happen? The candle, mamamatay yung apoy, di ba? Mamamatay yung apoy ng candle. Bakit? Kasi nga, nawawala ng oxygen yung bote. Because nagagamit siya sa reaction. So, oxygen becomes a limiting reagent pag ganon. So, kapag naubos na yung oxygen, the reaction will stop, hence wala ng apoy. Okay? So, yun. Siyempre, kapag industrial fire yan, for example, pabrika, hindi mo na mapapatay yung oxygen dyan, no? Laki ng pabrika yan, no? So, we have to use fire retardant talaga, no? Yung mga foam, no? So, ganun lang. Basta yun lang. So, that's one reaction of your alkane. One is the halogenation reaction. So, ito yung halogenation reaction natin. So, you have your alkanes that is reacted with your halogen. Ano yung halogens natin? Cl2, Br2, no? So, when they react with halogens, Cl2, Br2, for example, sila lang naman yung most nakikita natin most of the time. So, if they react with chlorine gas and bromine gas, ito yung formula nila, Cl2Br2, they will form a monosubstituted alkane. Okay, ano meaning ng monosubstituted alkane? Isang molecule, isang atom lang ng yung halogen ang kakabit sa alkane. Wala akong COVID. Umubo lang talaga. Katailalan ko eh. Okay, so mangyayari dyan, this is your halogen. Kakabit lang siya sa methane, no? So makipag-substitute lang siya with the hydrogen, no? Okay, if we further react this, no? If we further react our halogens, we will have more halogens in our alkanes. Finally, mawawala na yung hydrogen, you will be left with puro chlorine na lang, no? Okay, so mamaya daanan natin to, no? So, halogenation reaction is a substitution reaction. Ano lang nangyayari dito? Originally, you have your carbon attached to hydrogens, no? However, when we have reactions with halogens or halogenation, what happens is that your hydrogen is being replaced by your halogen. No, yung H papalitan ng Cl or ng Br. So you will have chloromethane, dichloromethane, trichloromethane, etc. No? Mamaya pakita natin yan kung paano nangyayari yung reaction. No? Okay, punta muna tayo sa last part ng PowerPoint. No? Saan ginagamit itong halogenation product ng alkane? So we use them as refrigerants. No? The general term for refrigerants are the chlorofluorocarbons. No? Ang ginagamit naman na halogen dito ay fluorine gas. No? Halogen used. No? Instead of chlorine, meron din palang chlorine. So, meron kang chlorine and fluorine na ginagamit for the halogenation reaction. So, basically, itong F and yung Cl ang pumapalit sa hydrogen ng iyong alkane. Okay? So, saan sila ginagamit? So, they are used as heat transfer agents in your refrigeration system. So, ito yung mga nasa ref, no? The common refrigerant sa ating ref ay yung Freon, no? Ito. Kasi yung aming ref, madalas pinapalitan ng Freon, no? Medyo luma na eh. So, yan. So, kaya familiar ako dito kasi yun nga. Okay, so itong Freon, ito yung nilalagay sa likod ng ref, no? 'Di ba makikita nyo sa likod ng ref nyo may coil. So within that coil may dumadaloy na chlorofluorocarbon. Okay, so that is used to transfer heat from your refrigeration systems, no? So sila yung nagta-transfer ng heat palabas from your inside ng refrigerator papunta sa labas, no? Kaya mainit sa likod ng ref. Nilalabas ng CFCs or ng chlorofluorocarbons yung energy from your material sa loob ng ref. No? Kaya lumalamig yun nasa loob. Okay? So, saan pa ginagamit yung CFCs? It is also used as cleaning material Ito ginagamit to panlinis ng mga laptop, no? Mga computer devices. Ini-spray lang sila. So, mabublow away yung dirt, no? And it was also used as propellants for aerosol sprays, no? Uso to before yung hairspray, 'di ba? Yung hairspray parang Lysol 'yan, pero hindi Lysol, no? Naka-can siya, tas yung buhok nyo igaganon nyo, tas spray nyo. Mas matigas na yung hair nyo. Okay? So ano yung downside ng chlorofluorocarbons? Ano alam natin with our CFCs? Sila ang nag-cause ng pagkabutas ng ozone layer, no? Our chlorofluorocarbons are reactive with ozone layer plus the UV ray from the sun. So ano mangyayari doon? So sisirain ng CFCs ang ozone with the help of the UV rays from the sun, hence creating the ozone holes, no? So ano itsura ng ozone hole? Ah, punta tayo sa windy app. Tignan natin yung bagyo. Ay, malayo na yung bagyo. So, wala nang suspension. Mabuti naman. Saan yung ozone? Ito. So, ano yung itsura ng ozone hole? Okay. So, tingin lang tayo sa baba ng Earth. Ayan. So, almost the entire region of Antarctica ay butas ang ozone layer. So that means this region of the Earth receives higher ozone content, no? Mas mataas yung ozone, mas mataas ang UV rays na natatanggap ng mga tao diyan compared to the regions na hindi butas ang ozone layer, no? Okay, kasi kapag butas yung ozone layer, yung UV rays from the sun dire-direktang papasok sa Earth, no? Okay? So as pag dire-direktang pumasok yan sa Earth, it can cause certain diseases, skin disease such as skin cancer, no? So, kapag tumama yung UV rays sa ating balat, it can cause cancer. Kaya we use sunscreens, no? Okay? So yan. So yan yung naging concern before, no? This happened around 1960s when the use of CFCs are prevalent, no? So hindi lang siya ginagamit sa refrigeration dati, ginagamit din siya sa hairnet. Alam niyo naman yung hairstyle ng 1960s, 'di ba? O napapanood yung mga Beatles, no? Ano yung itsura ng mga buhok nila, mga nakapataas, 'di ba? Mga punkista, mga nakapataas din yung hair, so ini-spray nila yon with hairnet. Those hairspray pala. So yung mga hairspray na yon, may mga CFCs yon. Over time, they accumulate in the atmosphere and they become concentrated in the South Pole. And since concentrated sila sa South Pole, binubutas nila yung ozone layer doon. Okay? So as a result, yung UV rays dire-direkta na papunta sa surface ng Earth, no, sa Antarctica. So however, because of this discovery na nabubutas yung ozone layer dahil sa chlorofluorocarbons, hininto na nila yung gamit ng CFCs, no? Yan, malaki yung butas na yan. Okay? So, pinalitan nila yon. Of course, bakit? Kasi nasisira yung ozone layer, no? Ayaw naman natin mabuhay sa mundo na puro UV rays yun nasa paligid, na every time na lalabas tayo, sunscreen. Parang ngayon, no? Pagkada labas natin, naka-face mask tayo, naka-face shield, no? Pagbutas yung ozone layer natin, kada labas natin, kailangan natin sunscreen. So, to prevent that from happening, gumamit sila ng replacements, no? So, instead of using chlorofluorocarbons, which causes destruction of the ozone layer, we use the simpler versions na lang, the hydrofluorocarbons or the hydrochlorofluorocarbons, no? So these compounds are less toxic, no, less destructive than the ozone. Less destructive sila compared to the CFCs, no. Okay. So yun, and they usually become destroyed before they eventually reach the atmosphere, no. Nasisira sila bago pa sila makapunta sa ozone layer. So safer sila. Okay. Sometimes nga alkanes yung nasa ref, no? Kasi napansin ko, yung chest freezer namin dito, ang nakalagay doon sa likod ay pentane. Sabi ko, pwede pala yung pentane gamitin as refrigerant. Pwede nga, no? So, yun. Sometimes they do not use this HFCs or HCFCs, no? They use alkanes na lang, no? To prevent the issue caused by the CFCs, no? So, yun yung good thing. Okay? So ito yung ating mga CFCs, ito yung mga kanilang potential harm, especially in the global warming, no, and the destruction of the ozone layer. So yan, listed sila. So as we shift away towards the use of CFCs, ayun. So mas bumababa yung potential niya to harm our environment, no. Okay? So yeah. So thankful na lang tayo na na-discover yon, kasi if not, if we're still using CFC, siguro patay na tayong lahat dito. Lahat tayo may cancer na. No? Okay, so that ends our alkanes, no? By the way, punta muna tayo, balik tayo sa reaction, no? Para tuluyan na lang natin. Okay. So, balik ulit tayo sa reaction ng alkanes, especially the halogenation reaction. Madali lang to. No? So, paano yung gagawin natin reaction dito? So, according to this problem, we have to draw the possible monochlorination products used by this, given by this reaction. So, basically, ang gagawin lang natin is maglalagay lang tayo ng Cl. No? Isang Cl lang. Kasi sabi dito ay monochlorination. And yan lang din yung ibibigay ko sa inyo to make things simple. Okay? So basically, what we will do here is that we will substitute one hydrogen with one Cl. For example, we have this molecule, the cyclohexane. If that is going to undergo a monochlorination reaction, ano mangyayari? Yung isang H, papalitan lang ng isang Cl and we're done. Okay? So, ganun lang. Plus HCl. Bakit naging HCl? Ba't may plus HCl? Kasi yung isang H dito sa ating cycloalkane, kinuha natin yung isang H, pinalitan natin ng Cl. Okay. Kaya napunta yung isang Cl doon. Plus, the combination of the removed hydrogen and the remaining Cl. Okay? So, yan. Tinanggal natin yung H, pinalitan natin ng Cl. So, saan mapupunta yung isang H? Yan, mapapartner niya yung katabing Cl doon. No? Diba dalawa yan? So, ito yung isa, ito yung pangalawa. Basically, nag-switch lang sila ng partner. Every time the partner switches, we call them substitution reaction sa organic chemistry. Substitution reaction, papalit lang ng partner. Okay, so that's one product. Okay, so let's have letter B. Ano yung possible products dyan? What's this? 1, 2, 3, 4, 5, 6. That's hexane. Okay, so yan ay hexane. So what are the possible products? Pwede, yung palitan niya na hydrogen ay yung nasa first carbon. Okay, pwedeng ganyan. Pwede yung palitan niya ay nasa first carbon. Ano pa yung pwede niya palitan? Nasa gitna, second carbon. Oopsie. Pwede yung palitan niya na hydrogen ay yung nasa gitna. Itong nasa second carbon. Okay. Ano pa yung pwede niya palitan? Yung nasa third carbon. Okay. So, yan yung ating mga products. No? So, we can have a Cl attached to the last carbon, a Cl attached to the second carbon, Cl attached to the third carbon. No? Sir, pwede po ba na nandito yung pwede po ba yung Cl? Pwede rin. However, these two compounds are the same. Same lang yan, dalawang yan. Ano name neto? This is 3-chloro-hexane. Yung chlorine nyo nasa third carbon from the left. No? If I'm going to give it a substituent number, 1, 2, 3. Nasa third carbon yung chlorine mo from the right. No? Okay, so yung magiging locant ng iyong Cl ay 3 instead of 4. Okay? So, ang name niyan ay 3-chloro, pangalanan nga natin, 3-chlorohexane. So, basically, you have a hexane parent chain. Nasaan yung chlorine mo? We call chlorine the chloro. No? Chloro. Nasaan yung chlorine mo? Nasa 4 or nasa 3? So, syempre, use the lowest number, nasa 3. So, 3-chlorohexane. Is this molecule the same as this one? Yes. No? Parehas lang yan, 3-chlorohexane. Bakit? Let's prove it. Maglagay tayo ng locant numbers. Okay? So, mapapansin mo, from right to left, ang carbon number nito ay 4. From left to right, ang carbon number nito ay 3. So, we assign the lowest number still. So, 3 pa rin yung kanyang name, no? So, 3 pa rin yung locant number ng Cl na yan. So, basically, yan na lang yung idodraw ko. Anyway, hindi ko naman kayo siguro bibigyan ng naming for this compound na. So, okay na yung ganyan na. Basta keep in mind lang kung sino yung mga same compounds, sino yung magkaibang compounds na. Just flip the molecule. Just what I told you last time. Pag flip mo yung molecule, it appears to be the same as your original molecule. Then they are not isomers, no? They are the same compounds, no? So these are our products for the monochlorination of the cyclohexane. The Cl at the end. So this is 1-chlorohexane, ang name niyan. Your Cl on the second carbon, this is 2-chlorohexane, and then this one, your 3-chlorohexane. Pag yung Cl mo nandito, 3-chlorohexane pa rin name nun. Okay? So, ganun lang. So, yan yung tatlong products. Of course, plus the HCl. Okay. Yan. So, yung Cl mo, pwedeng kahit saan siya kumabit, no? Yan. Let's have letter C. Ganyan na naman ka-simple yung ganap natin. Papalitan mo lang talaga. Letter C. Saan pwede ilagay yung Cl? Pwedeng nasa dulo. Pwedeng nandito sa dulo. Pwedeng nandito. Okay? So, ganun lang. So, lagay natin. So, yan yung nasa dulo. And this one, ito yung nasa gitna, no? And the HCl plus HCl. Okay? So, this is the monochlorination product. So, anong mangyayari? The hydrogens at the terminal carbon here, papalitan siya ng isang Cl. Okay? Giving you this compound. Sir, pag nilagay ko yung Cl dito, is that a different compound? No. Same lang yun as dito. Pag dito ko po nilagay yung Cl, is that a different compound? No. Same lang din yan dyan. Pag dito, same lang din yan dyan. Okay? So, same lang ang structure whether you place your Cl here, 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 and there. Kung kahit saan mo ilagay dyan, ito lang yung representation nun. Okay? So, ito naman, this is another version, this is another isomer of this compound wherein your Cl is not attached on the terminal carbon, rather, it is attached on this carbon. Okay? So, dito natin dinugtong yung carbon. Pag dito ko nilagay yung Cl, I mean yung chlorine. No? Pag dito ko dinugtong yung Cl, you have this compound. Pag nilagay ko po dito yung Cl, is that a different compound? No. Ito pa rin yan. You just reverse the molecule. I-flip mo lang yung molecule mo. So, they are still the same. Okay? So, always, it is important for you to check if kapag flip mo yung molecule, magkaiba sila. If they appear to be the same, then same compound yan. Okay? So, kaya ganito lang yung drawings natin. No? Dalawa lang. Plus the HCl. Yun sa dulo yung pinalitan. Itong nasa gitna yung pinalitan. So these two are different compounds. Okay, so basically that's the end of the alkanes. No? Next meeting, we will discuss alkenes and alkynes. No? So I want you to read that in advance. No? And regarding sa next week classes, no? Say last night, no, I was reading Facebook, ano, may Facebook feed. Nakita ko yung post ng FEU, Student Central Organization. Basta yan, no? Yung student org ninyo na, na panglahatan. I saw that they are drafting a petition to have a week-long break, no? Starting November 1 until November 7. So, in times that if ever the petition was granted, then ibig sabihin nun pahinga tayo for that week, no, the undas week, no. So from November 1 to November 7. However, if hindi yun ma-grant yung petition, so magkikita tayo na November 3. Yeah, magkakaroon tayo ng classes sa November 3 kung ganun, no? But we'll see, kaka-post lang nila kagabi, no. So anyway, yun lang naman, share ko lang. Tapos na tayo sa alkanes. So basically, what we discussed today is yung cyclic compounds, the cyclic alkanes, how to name them. Still the same as your typical alkanes now. Same pa rin ang naming process. Then we added the conformation ideas. Ano meron sa conformation? The 3D arrangement of your alkanes, the cycloalkanes in particular. So depending on the position of your substituent, you can either have a trans or the cis isomer. We can tell kung sino yung trans, kung sino yung cis by just looking at the bonds. No? If you have a wedge or a dashed bond. Wedge bonds tell you that the substituent is pointing towards you, pointing sa iyo, yung substituent na yon. If that's a dash, if that is a dashed na wedge, no, it is pointing away from you. If it happens na parehas silang pointing towards you or parehas silang pointing away from you, then you have your cis isomer. If magka-opposite yung direction nila, one is pointing towards you, the other is pointing away from you, then you have your trans isomer. Tapos ano yung diniscuss pa natin? The physical properties of alkanes. What we know about alkanes is that they are non-polar. So that means they will not dissolve in polar solvents such as water. No? Hindi sila halo sa tubig. Rather, they will dissolve themselves into another non-polar solvent, another alkanes. No? So, ganun. Ano pa? Ayun, so since our alkanes, they are non-polar, hindi sila polar, ano mangyayari? Ayun, so magfa-follow lang sila ng London dispersion forces, no? So we'll just follow the London dispersion forces na intermolecular force, no? So according to London dispersion forces, the higher the number of electrons, the higher the boiling point, the higher the melting point, no? So as your alkane chain grows longer, ibig sabihin nun, mas mataas yung kanyang boiling point and melting point, no? So yun lang. Whenever you have more substituents, the more branching or the more substituent you have, what happens to the intermolecular force? It decreases. Bumababa yung intermolecular forces because of the surface area. Lumiliit yung molecule kapag nagkakaroon ka ng branching. So as a result, since the molecule shrunk, no, lumiit yung molecule mo, so mababa yung kanyang surface area, causing for the London dispersion forces to be decreased. No? As a result, bababa yung melting point, bababa din yung boiling point. Then finally, sa chemical properties ng ating alkanes, we know that alkanes can undergo combustion reaction, which is just the reaction of your alkane with oxygen to form carbon dioxide and water. And pwede rin na mag-undergo sila ng halogenation reaction. What is a halogenation reaction? Basically, your alkanes, no, yung isang hydrogen ng iyong alkane that will be substituted with a halogen. What is a halogen? Sila yung nasa group 7. Fluorine, chlorine, bromine, iodine. No? Okay, so sila yung pumapalit sa hydrogen. So, for these examples that we have here, we have the monochlorination. Hanggang dito lang yung ibibigay ko sa inyo. No? So, yan. So, monochlorination, ano mangyari dyan? Yung isang hydrogen, papalitan ng isang Cl. Okay? So, yan yung mga products natin. Okay? So, make sure na you draw the isomers, no? All the possible isomers, no? Okay? Paano po kapag dichlorination? Meaning nun, dalawang chlorination. Dalawang chlorine yung gagamitin. Okay? Okay? So, ganun. Yung isang Cl nandito, yung isa nandun, yung isa nandyan, yung isa nandito, yung isa nandun, yung isa nandun. So, anyway, hindi ko na ibibigay yan to make things simple kasi marami pa tayong i-cover in the future. Okay? So, that's it. That's the end of our alkanes. By the way, bago ko makalimutan, yun nga, yung CFCs, the environmental importance ng topic na to is itong discussion on the CFCs. No? Yun nga, we know that CFCs destroy ozone, our ozone layer, no? Yung ating ozone molecules. So, we use other replacements, no? Such as the following. Okay, sometimes yung ating refrigerators and coolers, no, they use alkanes na lang, no. So effective din naman. Mura yung kuryente ng aming chiller eh. So yan, effective din yung alkanes in removing heat. Okay, so yun lang. So basically that's the end of our discussion. No. Next meeting na lang yung alkenes and alkynes, no? Para hindi kayo info overload, no? So medyo marami tayong i-discuss next meeting. This is 31 slides, no? So please read them in advance, although the same concept applies to alkanes din naman, no? So yan. Anuhin lang natin to. Speed lang, no? Okay. So yan lang. Kaya yan, no? Kasi alam nyo na yung alkanes eh. Kasi sa organic chemistry, as long as you know the alkanes, you can proceed with any organic molecules na. Especially yung naming, parehas lang din ng gagawin. No? So, yun. So, with that, we're done with our discussion today. No? So, if ever na may classmates kayo na hindi maka-attend because of the internet issues or the kuryente issues brought by the Typhoon Kinta, so sabihin nyo na lang, uploaded naman to sa YouTube na. And yun, when it comes to deadline, siguro, for this chapter, hahabaan ko yung deadline na. Kasi may bagyo eh. Onti lang tayo. We don't know what happened to our classmates, no? Kung safe ba sila or walang kuryente, no? Kasi, may mga kilala ko na students ko dati na naging affected din ng typhoon, no? Especially those who are in the Bicol region and the tawag doon, the Mindoro region. Doon tumama yung bagyo eh, di ba? So medyo affected sila. Binabaha, no? And stuff, no? So yun lang. For the chapter quiz, no? Hahabaan ko yung deadline for those people who are affected by typhoon to catch up, no? So yun lang, tulungan nyo na lang yung mga classmates nyo academically pag may issue sila, no? Such as that, no? And they can also reach me out. So yun lang. Dun lang po natatapos yung lesson ko today. So I still want you to keep safe, no? Kasi tapos na yung bagyo. We have still COVID-19, no? So stay safe, no? And I'll see you again next meeting, no? Meron ba next meeting? Ano ba ngayon? October 27. Meron pa pala next meeting. October 30. Kala ko na Semana Santa na, excited magpahinga yun. So yun lang. So I'll see you on Friday na. So stay safe and update na lang tayo. Check the FEU Student Central Organization or Central Student Organization. Check nyo kung magkakaroon sila ng postponement of classes next week. No? So yun, so stay safe and goodbye. No? Have your breakfast muna and enjoy your day. Okay, so bye-bye po.